So the major idea of this course is to take what you already know from one variable and move it over to multiple variables. Okay, so who watched that brief little video I put up? Okay, there's a Quarkus announcement with a little video. Okay, for everyone who didn't watch that video, you're about to see it again. So in one variable, there are kind of two techniques that we care about. Right? So we care about the process of calculating slopes. We want to find slopes of things. Right? So this process of finding a slope is what we call differentiation. Oh, hello, welcome. You missed the very awkward exercise that we just did. Yeah, no, you missed all the fun. That's okay. All right, so we care about this process of finding slopes, right? And that is the process that we usually call differentiation. Can I get that a bit differentiation? Can I get that a bit louder? Yeah, great. We're going to do differentiation in this course. So this is the process of differentiation. And the other process that we do a lot of in a first-year calculus course is finding areas or regions under a curve. Okay, so we also have a notion of area. Okay, and to find areas, what do we do? Integrate. A bit louder? Integrate. Amazing. Okay. Okay, so you're all experts in this in one variable, right? You've seen how to do this when there's one variable. What we're going to do in this course is we're going to generalize up one dimension, okay? So in the context of our course, we're going to be looking at 3D things most of the time. Okay, so we'll have an x-axis, a y-axis, and a z-axis, and we'll be doing similar types of things, but with two variables. Okay, so we'll be looking for slopes, but instead of having these tangent lines, we should get some kind of new higher dimensional thing. Right? So what should we get? We should get tangent planes, right? One dimension up we get tangent lines? Lines, planes. Tangent planes. So we'll get little surfaces like this. So we'll go from having tangent lines, we'll move up a dimension. We get something called tangent planes. One of the things about this course is that somehow I feel like it's like the better or truer version of calculus. This is just my feelings about it, but first year calculus, there's lots of things that are kind of too nice because you've only got one variable. Everything kind of works really nicely. It just all fits together. one of the aspects of single variable calculus is that if we've got a single variable, there's only one kind of derivative. Right, so we say, okay, we take a derivative, we put a little dot there. Just to check, people in the back row, can you see the writing? Yeah, it's all right? The size is okay? Sweet. So we get one kind of derivative. Now, what would happen if we had two variables? Right? We wouldn't just have one variable anymore, so we couldn't just write one little prime here, or one little mark there. Yeah. So things will generalize a little bit. We'll get more directions in this course. Okay, so we're going to get something called a partial derivative because there's more than one direction that we can go in. We can go in the x direction or we can go in the y direction. And those will give rise to two different notions of derivative. Okay, so these curly things are not the number 2. They look a lot like the number 2, but they're supposed to be a fancier letter D. Okay? So the way that you write that symbol, kind of a big swirl like this. Okay, that means, I guess question.
So that's what the name of the symbol is.
Right. I don't know. I pronounce it D, so I just say.
All right.
If you write LaTeX and stuff, I can show you how to write it in LaTeX, but we'll do that later. If you write math on a computer. Okay, so one of the things that'll happen is we'll get two notions of derivative. We'll get a derivative in the x direction, a derivative in the y direction. Okay. What should happen to our notion of area when we go up a dimension? We've got this notion of area, this integration. What will happen one dimension up? Think about that for a moment. Right, and then chat about it with your neighbor for a moment. Just like 30 seconds.
I think it's partial integration. Is that what we did last time?
Okay, what should we get when we look for integration in two variables? What should we get a measure of? Yes. Yes, we should get something that measures volume, right? So we'll get like some region in here, and when we integrate over that region, we'll get a like some amount of volume, like in a water bottle. Right, so we'll get right, well, instead of getting a 2D thing, now we'll get a 3D thing, and we'll get volume is our notion of integration. And our notation will change a little bit as well. Okay? So usually over here, right, we're writing one integral sign. Because we've got one variable to deal with, right? We've got the x variable. On this side of the picture, we've got more stuff to work with. Okay, so we've got two variables, so we'll write two integral signs. And we'll say that we're integrating in x and then integrating in y. Does that notation leave anything out? Something missing? Maybe people who did like AP or something will. The bounds, right? There's no bounds in this notation, so we'll put in some bounds. Okay, so there's really, really strong analogies between what we're doing in one dimension and what we'll be doing in two dimensions. So for 99% of this course, we're going to be in two dimensions. Okay, we'll be on this side of the picture. In week 12, the very last week of class, we're going to say that the same thing happens in all dimensions. Okay, so we're going to deal with two dimensions for about 11 weeks, and then at the very end, we're going to talk about what happens in 1,000 dimensions. And what winds up happening is that the math kind of works out the same way, which is really neat. When I took this course, I was really like blown away that we could calculate the volume of 7-dimensional objects. Whoa. You know, I thought that if I studied a lot more math, I would like be able to like see in 7 dimensions. And I can. No, I mean you'll wind up developing an intuition for how high-dimensional things work. Okay? By the end of this course, you will actually kind of be like, yes, 4 dimensions. You will. Which is kind of cool. But we'll get there. Okay, we're going to spend a lot of time in this kind of zone where we can draw pictures and like, you know, graph things, and then we're going to go at the very end of the course to higher dimensions. Yeah. Questions there before we go on? So there's the notation. Yeah, so that's kind of the sort of the plan of the thing. I would now like to take a 5-minute break if people have questions and would like to come up and ask, or if you want to go have a smoke, or go for a walk, or have a glass of water.